Hello, this is Mr. Pascoe with another lesson about networks. This one is about adjacency matrices and how we use them to represent a network graph that we've got a picture of. So here's a graph here that's connecting up A, B, C, and D and E. And that's a picture we can look at, and it's very easy to see the connections. I kind of like the picture diagram myself. But you can also make a matrix of what the A, B, C, D, E connections, what they all are, and put them in this matrix. And when we did adjacency matrices previously, or matrices in chapter 4, they had a line of zeros diagonally down here. Now in this chapter, in this one that we're looking at today in chapter 5, they can have other numbers in the middle. It doesn't have to be a zero. And we've got D here joining up with D, with a 1 in it rather than a 0. And that's because D has this thing where it can go round in a circle, and you can keep going round in a circle and getting back to D. So it's kind of like you take this little walking path out of town, and then you can ride round on your bike maybe and come back again and just do laps and just keep going to D over and over. So there is a path that goes from D to D. You don't just stay in the one spot. You can go along this path and move along. All right, so that's going to be something new. Let's have a look at where we're going to next. So it's kind of like that dog. My dog Murphy does that sometimes, chases his tail round and round and round. So that's a new thing where we can just keep going round in a circle and not actually go anywhere. We're staying on the same vertice dot. And so what the adjacency matrix does is it records the number of connections between those vertices or those dots or those A, B, C, D, E's in a network graph. And you can have these little round circle loops where you just go around in a circle without visiting anywhere else, when you keep just ending back where you started again. So you can follow a circular path just from one vertex back to the same vertex. And that's called a loop. When you go round and round and round in circles, that's a loop. Okay, I'm getting a bit dizzy on this slide, so let's get on to the next one. All right, so a non-zero value, so usually this diagonal in an adjacency matrix, when we looked at it before, had all zeros in it. But if you see a 1 there, what that means is that you've got something connected to something else with a loop. So B connects to itself with a loop. So B has a 1 instead of the usual 0. Because see this, that pink loop is just where we've colored it in to highlight it. But see in the network diagram, you can just go in this loop and keep going around in a circle and only ever visit point B on the network. Okay, so that's a loop, and that's something new. Now, Jackie Chan bring up good point here. He say, why need matrix when I have diagram? All right, because yeah, the diagram's a lot easier to look at, and you can see exactly how A, B, C, and D connect up, and it's a lot easier to look at than this matrix. So why do we have this matrix when we can just use the diagram? All right, very good point, Jackie, and we're going to answer that question for you right now. We need the adjacency matrices for computers because they use matrices to process the network interactions and connections. So if you want to do any network analysis with a computer, which you do because networks get very big and complicated, you need a computer to work on them. Computers have no eyes and no brain, and they can't look at network diagrams. So they don't have a set of eyes to look at this network diagram and see what's going on like we do, or even animals could do that. The computer is really dumb. So yeah, a lot of people, especially older people or people who haven't used computers, you know, they've said to me like, oh, it's so much easier for you because you've got a computer and computers do all the work for people these days. Well, no, they don't do work. All they've done is make a lot of extra work for people to program them and set them up to do things. Okay, computers are not intelligent. Whether artificial intelligence will ever get anywhere, who knows? Supposedly by the year 2000, we were supposed to be flying in cars instead of driving along roads. And here it is 20 years later, and we still don't have cars flying around. We're still driving on the roads, and a lot of us are still using up gasoline or petrol, but let's not get into that rave. Okay, so the computer needs the adjacency matrix. It needs this numerical representation so it can get all the connections put inside it. And then these are called arrays in computer science. And matrices or arrays can be put in the computer, and then the computer can understand what all the connections are, because it has no eyes and no brain to look at a pictorial diagram. So that's the whole reason why we have to do this lesson and why we have to do adjacency matrices. It's because that's the way computers deal with networks and doing than using matrices. So an extremely important property of adjacency matrices is this thing called the diagonal symmetry, and we'll have a look at that now. So something else which you may not notice before about these adjacency matrices when we did them in the previous chapter is that if you rule a diagonal line down the middle, it's kind of like looking at a mirror, and whatever's on this side should be exactly the same on the other side, just like looking in a mirror and seeing the mirror reflections. And see, going down this diagonal line, which cuts the matrix in half diagonally, we've got a 2 on this side and a 2 on that side. So that means that B and A have 2 connections, and of course, going the other way, A and B also have 2 connections. So that makes sense, because if there's 2 paths leading from A to B, then there must also be 2 paths if you want to come back the other way going to B to A. And here we've got a 0, and we've got a 1 on each side. Here we've got, along that line, we've got 2 zeros on this side and 2 zeros reflecting exactly the same on the other side. And down the bottom here, we've got a 2 on one side and a 2 on the other. So it's just like a mirror image, and that's what you see in adjacency matrices. And that's an extremely important property which we're going to be using in the questions that we do. So that's something you need to understand, the mirror image or the symmetry down the diagonal that goes through the middle. Telling you a twins apart level expert. Yeah, and that kind of neat haircuts for little kids, very neat. All right, let's get on to the next thing, and we're going to actually have a look at an example here, and we've got an answer so we can kind of cheat as well. But let's just try and get into these pens and things and see how we go here. So you have to draw up a table. So here's the network. Now I can't even see where my thing is now. Here's the network diagram we've got. I don't know where my pointer is. And here's A here, okay? So there's point A. So we start at point A, as they tell us here, and we look at all the connections from A to B to C to D to E to F. Okay, so let's have a look at this. So A, we're starting off with A. A goes to B, and there's only one connection there going to B, okay? So for A going to A, well, we don't have one of those little loopy things coming round. So we don't have one of those loops where you go around in a circle. Let me just see if I can get this thing working. I'm so not very good with this pointer stuff. Pointer options, I need an eraser. Where's my eraser? There it is. Let's get rid of that loop going around there because we don't have that. And let's try and get back onto the pen thingy. Am I back on the pen? No, I'm still on the eraser. Okay, pointer options, we want a pen. Okay, so A to A, we don't have one of those loopy things, so that's a 0. And A going to B, we've got one path. If we want to get from A to C, you can go down here. That's one way of going, but you can also kind of go in that little loopy path as well. So it's actually 2 ways from going to A to C, so we put a 2 there. Going from A to D, we've just got this one straight line path that's the only direct connection between A and D, so that's just a 1. Going from A to E, there's one path here that's a direct connection, so we've got 1 there. And going from A to F, we've got this one path that goes along here, so we've got 1 to there. So let's check our answer. I wasn't looking then, I wasn't cheating. We've got 0, 1, 2, 1, 1. Okay, so that's A done. So let's just see if I can... I had this working before when I practiced. Here we go. Now I go to the eraser. Let's just rub out all those A things because we're finished with A. And that one's being stubborn and won't go away. Now we're working. Now let's get on to ink color and change to a blue color. And okay, let's have a look at B. B for blue here. So B, what sort of connections we got? Well, we've got one that goes from B to A. So working on B now. So I got B to A, there's 1. B to C. We don't have a connection from B to C by the looks of it. B to D. There's no direct connection either. B is kind of a little bit isolated out on its own. There is a B to F connection, so we could put a 1 there. Now B going to, what's this? B going to D. Is there a B to D? No, there isn't. B going across to E. E's over here, B's there. No, there's no connection there, okay? So that's got a lot of zeros in it and a 1. And then we need to go on to C, so let's do that. My thing doesn't want to work now. So annoying. Alright, so pointer options, let's get the eraser out. And let's get rid of that scribble we did for B, and we'll just do C, and then that's probably enough. So we need a different color, ink color. Let's go for a purple this time. Alright, so here's C, and for C, what have we got? We've got C going to A, and there's that connection, and there's the loopy connection. So there's a straight line, and the other one, so we've got two going from A to C, which makes sense because from, A to C we had two, and so going from C to A, there's two ways to go back. So there's two ways to come from A to go over to C, and of course there's two ways going back as well. All right, now C going to B. Is there a connection between C and B? No, B's over here, and there's no direct connection, so that's a 0. C going to C. We don't have one of those loopy things, so that's a 0. And C going to D. There is one connection there, a straight connection, so we got a 1 there. C going to E. C has no direct connection to E because here's E over here and we don't have a line going there, so that's a 0. And C going to F. F's over here and there's no direct line from C over to that point at F. So that's a 0 as well. Let's see how he went there. 200100. All right, now you can do this and finish the rest off, and you can see the answer over here on the right-hand side. But we do have one of those loopy things on F where you can go round and round like the little doggy in a circle, only ever visiting F. So when you do F to F, you do put a 1 in there. All right, now E going to E, there's no loopy thing on that. So for E and E, you'll just have a 0 in there. And for D going to D, again, there's no loopy one coming around that at all. So that will be a 0. So that's kind of your central point there. And what we should be able to do is a bit of cheating here. Because remember, it's supposed to be a mirror image each side. And you see that happening. There's a 1 here and a 1 over there, okay? Then we had a 2 on this side and a 2 on that side. Here we've got a 1 on that side. And what does that mean? Is that a 1, 0, 0? Yeah, there's a 1, 0, 0. So this would be a 1. D to A is a 1. And then we've got a, now it's a little bit hard to see, 1001 was going there. Then we've got 100. So that should be an 01, so that would be a mirror reflection. If you got 10, then you'd have 01 on this side. Here we've got 101, so here we'd have 101. And you can see that is producing the right kind of answer here. So we're going to get into that more later on doing the mirror reflection, but that's probably enough for that example. So let's move along. And we've got a couple of adjacency matrices to construct, okay, given the graphs. So that's kind of what we've just been doing. So that should be okay to do. So let's just get a new color here. So first we're looking at A. What does A connect up with? Well, A's here. And does A have a loopy thing coming round, spinning round in a circle? No, it doesn't. So A to A is 0. A to B, there is one straight line connection like that to B, and that's the only way, so that's a 1. A to C, let's have a look at A to C. A to C, we've got one connection like that. A to D, we've got one straight connection like that. A to E, there is no connection going from A to E. All right, so we've got 0, 1110 going across there. Now we have a look at B, so we probably need to get our eraser. I'm going to have to try and get quicker at doing this. Let's get our eraser. We've done all the A stuff. All right, so let's get a different color. Let's go for a blue. Again, no, let's not go for blue. Let's go for a different color. In color, let's go for red. All right, so B, let's have a look at B. Does B connect up to A? Yes, it certainly does. So we've got a 1 there. Does B have a loopy thing going around? No, it doesn't have one of those. It hasn't got a loop, so there's nothing there connecting B to B. Does B go to C? Certainly does. There's got a connection there. Does B go to D? No, B's here and D's over here. There's no connection between them, so that's a 0. Does B go to E? Yes, B connects up to E there. So that is a 1. So we should have 1, 0, 1, 0, 1. That's looking good. So B's done. So yeah, it's just a matter of kind of working through this, and it's a little bit painful and boring. But this is all the hard work humans do. We thought the computer was supposed to be doing all the work, and it could just look at a diagram and figure out how to make a matrix. Yeah, well, the computer can't do that. This whole thing about computers making life easy and doing all the work for us is one of the biggest lies you will ever hear in the world. And the world will tell you a lot of lies if you haven't figured that out already. But anyway, I'm ranting. C to A. So let's go here. C to A, we've got one. C going to B, yes, we've got one there, so that's all good. C going to C, there's no loopy thing around that, so that's a 0. And C going to D, no, D's over here and C's here, and there's no connection between them. So C going to E, C's here and E's up there. We do not have a straight line going directly or a curvy bendy line, we've got nothing. So that's a 1, 1, 0, 0 there. All right, so we've got 2 more to go, D and E. So onto the eraser, get rid of all that junk. All right, and we need a new color. What will we use? Red. We'll use red again. Okay, so up to D. Let's have a look at D. D does go straight up to A. That's good. D goes to B. No, D's here and B's over here. We've got no connection there. D going to C. D's here, C's over there. We do not have a direct connection. D going to D. No, there's not one of those loops, so that's an O. And does D go to E? It certainly does. We've got a connector straight up there for that. So that's 10001, and we've got one more to do. I'll just rub out all of this. And for this one, we'll go back to ink colors. Now we can't use green because I think green's not good for colorblind people. So we're looking at E now, E, and we're on blue pen again. Okay, so E going to A. E's there and A's over here, and there's no direct connection, so that's a 0. E going to B. Yes, E does have a direct connection to B, so that's okay. E going to C. Well, E's here and C's over here, and there's no direct connection between them, so that's a 0. E going to D. Yes, we do have a straight connection there for E to D, so that's a 1. And E going to itself, no, we don't have any loop thing there, so that is a no for that. So that's a 0. So we've got 0, 1, 0, 0, 1. 0, 1, 0, 0, 1. 1, 0, 1. E going to E, there wasn't one. Okay. Just looking at the answers in the back of the book for this, and they've got that round the other way, but I think they've got it wrong. Because D going to E, is there a connection for D to E? Yes, there is, and they don't have that. I think their answer's wrong, and I think our answer's correct. So that's that one, and we've got another big one to do over here. I'm not even sure how long we've been going with this video. Don't want it to get too big, but anyway, maybe that's the price we pay. All right, let's have a go. So A. Sometimes I have to do things to amuse myself. A, okay, now A going to B. No direct connection. So has A got a loopy-loop thing? No, it doesn't. So that's no. A going to B, there's no direct connection there. Now A going to C, yep, that's certainly happening. So we got a 1 there. Is A going to D? Yep, we've got that happening. So that's definitely a 1. A going to E is a connection, and we've got this curved one. So we've actually got 2 for going from A to E. And for F, A to F, A's here and F's over here. And sadly, we don't have any connection for that. So that's a 0. there. All right, so erasing out. All right, so you'll have lots of fun doing these. I guess in your textbook, if you're going to do this, you need to use the snipping tool if you've got the online version, and just copy and paste these into something where you can draw on them with your computer. Now B, let's have a look at B. B going to A, no, there's no connection there, which makes sense because A going to B, we didn't have a connection either. And remember, we've got this mirror kind of image stuff is going to be happening as well. So if we just dot in C to C, D to D, E to E, F to F. F does have a loopy thing on it, so F will have a 1 here. It does connect to itself, and C's got one of those loopy things too. So C to C will have a 1 in here. There's no loopy-loop things on any other letters, so we know diagonally that B going to B is a 0, D going to D is a 0, and E going to F is a 0. And then we can try and use mirror reflection along that line. So if we just kind of draw a whole bunch of dots in here and make it really messy. We've got a 1 on that side, so this would have to be a 1 here. Now we've got to find out what B to C is. Okay, B to C does have a join, so that's a 1. Okay, so if we've got a 1 on this side of that diagonal reflection there, the mirror surface, you should have a 1 on this other side as well to match up. So we can kind of use the mirror imaging a bit to help us speed things up here. Now B going to D, B to D. D's over here and B's here, and there's no direct connection, so that's a 0. And B, oh, sorry, I've done C to D. Well, C to D actually is a 0 as well, because there's no direct connection. And that's a 1 like that. And what do we got here? So if there's a 0 on this side just here, there should be a 0 over on that side there. So C to D, yes, C and D don't have any direct connection. So you can just use the mirror kind of thing there. B to E, B going to E, no, there's no connection. B's here, E's over there. There's no line connecting them, so that's a 0. And B to F, yes, there is a connection. So that's a 1 there. Okay, so on this side of here, we've got 2, 0, and then we've got 1. So on the other side, we should have 0 and 2. So that should work like that. And just double checking, E going to A, yep, there's this one and that one, so it does have a 2 there. So that's okay. What else can we work out? Anything else we can do mirroring at the moment? We've got 0, 0, 0 there. So I think we'll have 0, 0 like that. F going to A, there's no direct connection. B going to F. B going to E. There's no direct connection. So yeah, we can get some mirroring in there. We've got to work out D going to A. D's here, A's going over there. Yes, there is a connection. We've got to work out D going to B. Does D, which is here, have a direct link to B over there? No, it does not. So that's kind of that bit in there. Right, and we can sort of fill out all the rest of it, and we should have a 0, 1, 0, 1, 0, 1 here. And because we've got a 1 there, we should be able to mirror up and have a 1 here. So E to F, if we just double check that on a very messy diagram, E to F does not have a connection. So EF here would be a 0, not a 1. Now that 1, 0, 1, if I'd drawn this up neatly, that probably connects there. F to D does have 1 connection, so that's right. Then we've got double 1, these are all O's in here, and we've just got one more to fill out actually, E to D. E to D, E's here and D's here, and I can't see an E and a D connection, so I'd say that's a 0. So it'll be 1, all zeros 1. Yeah, so that's the finished matrix. Oh, we've missed a couple here. We've got to do C and E. C going to E, no, there's no direct connection there, and D going to E has no direct connection either. All right, so that's all the matrix finished. So that's 2 of the questions out of question 9, and I think there are 2 more for you to do. So that took quite a while, a lot longer than we were thinking it would. And now we've got to draw graphs to for these adjacency matrices. So a bit of a problem here. We'll have to label them A, B, C, D, and here we've got A, B, C, D, so I'll just write that in around the outside there. So A going to, no, we usually have them across the top, don't we? A, B, C, D. So A going to A is 0, all right, so you've got 0, and that's a 0, so there's no loopy things. A going to B, there's just one path, so I don't know how this is going to turn out. Sometimes they overlap and you have to redraw them. But A going to B, A going to C, well, there's no path for A going to C, and we'll just sort of draw these all over the place for now. Now, A going to D, there is a path, so we'll draw that in. Now we're on the B row here, looking at B. What's happening with B? B going to A, there is one, which we've already got drawn in. B going to itself, so there's no loopy thing there. B going to C, B and C do not connect up. And B going to D, there's one path, so that must go like that. So B can mix up with D. Now looking at the C's, we've got no connection between C and A, C and B. C and C is 0, so there's no loopy thing to draw. C does connect up to D though, so we do have a connector like that. And D connects up to A, we've got the one connection already. D is connecting up to B with one connection, D is connecting to C with one connection, and D doesn't connect to itself, so there's no kind of loopy thing. So that's the drawing for that. Now, if you look at the answers in the book, it might be kind of the other way around, but as long as it's showing the same connections in the drawing, both drawings are correct. Now, this next one is a lot more challenging, and there'll be 2 of these for you guys to do. So we've got A, B, C, D, and A, B, C, D, E down here. Now, A to A has 2, so that's really kind of wild. What that means is that there's one of these loops on A, okay, but A has another loop as well, kind of like a couple of party balloons there. So you can walk around this one and just only visit A, and you can go round and round in circles and only visit A there. Now, A is not connecting up to B, so A is not connecting to B. So let's just put B over here, and A is not connecting to it. A and C has one connector, so A and C, we'll just park C down here. So A and C do connect up, and looking at this first row, so we're just going across that first row. A to D has one connector, so we'll put D just here, let's say. So A and D connect up, and A and E do not connect, so we'll just have E down here somewhere on its own, I guess, like that. So there's E. All right, so I've done that. Now B doesn't connect up to anybody. Poor old B. So B's just going to stay out here on his own, and he's never going to connect up to anything because he's got zeros all the way across. How sad for B, he's a loner. C is one connection to A, which we've already drawn in, actually. We've got that one. C does not connect to B. No one connects to B. C connecting to C is a 1. So that must mean, because we've got that 1 in there on the diagonal, that must mean that C has one of those sort of party balloon loops on it as well. C connecting to D does not happen. And C connecting to E, there are 2 paths. So you must be able to kind of go from C to E like that, or you can go from C to E on another path like that. I don't know what happened with my pen there. So we've got 2 ways of getting from C to E. Now D going to A, there's one way which we've already drawn in there. I've already got that D to A line, so we're working on this one at the moment. It's not connecting with B, C or D, that's nice, but D does connect with E. So D here will connect with E. So we've got that connection in. Now E, the last one. E, it says here E does not connect with A. That's correct. We've got no direct line between E and A, so that's all good. There's no direct line there. E doesn't connect to B because B's out here all on his own, poor old B. There's two connectors between E and C, and we've actually drawn those in already because we did that when we were doing C to E. So going back the other way, E to C, there's also two connectors. E to D has one, which we've already drawn that one before. That's D just there. And E to E, there's no little round loop. So that should be the finished drawing for D. And I've got it up here and I'm just having a look. And yeah, that's pretty much like in the book. I'm not sure why they do curved lines on some of them. But as long as you got the same connections to the book one does look slightly different, their answer. But this answer here is correct as well. So let's give those a big tick and a smiley face because we're through with them. And on to the last sort of question, question 12, the adjacency matrices. Now, remember, the property of adjacency matrices is that mirror stuff down the diagonal, that what's on this side here matches up exactly with what's on the other side. So you can see if we draw the diagonals in, and we're going to do it with highlighter pen. Whoa, how about that? We've just done it. So here we've already got that. We've got 0 on this side and 0 on that side. Here we've got a 1 on this side. And what's going to go on the other side up here? Well, so it's a mirror, we'll need a 1 up there. Okay, here we've got a 2 on this side, and so over in here we need another 2, so that we've got mirror happening there. That 1 reflects with that 1 in the mirror. This 0 is reflecting with that 0 in the mirror. So that's the answer, 001, 022, and 120. So that one's finished, and that's correct. So these probably, I think, are the easiest ones. Let's see. So let's do the easy stuff first. 1 here needs to reflect in the mirror with another 1 down there. Here you've got a 2 and a 0, so up here to get the reflection you need a 2. And here we've got a 1 on this side, so in there we need a 1 to do the reflecting. And so this one has a 0 and a 1 on this side, so we got the 1 there, so that would have to be a 0, so that we've got the whole reflection on that one. On this side we've got a 0, so on the other side to make the mirror image reflection we would need a 0 there. Here we've got a 1 on this side of the mirror, so that side of the mirror would need a 1. So that's your final answer there. I'll just check it. 2100, 10, 12, 01, 01 and 0210. That is the right answer from the back of the book as well. So we're cooking, we were cooking really well here. Let's go back. Now, 0, 0, we've got a 0 on that side, so that will have to be a 0 on that side to match up. Here we've got a 1, so to get the mirror reflection we need a 1 in there. Here we've got a 0 and a 1, so over here you need a 0 and a 1 to get the mirror reflections on that side. This one has a 0 and a 0, so on this other side we need a 0, and we've already got that 0 up there. This side has 1, 2 zeros, so we've got one of the zeros there, so down in here we'll need the other 0, and here we've got a 2 on this side, so we need to have a 2 on the other side, okay? And that's finished that one. Now, for our final answers though, what we should do is, just to go through the agony one more time of using these pointer options, we should get the eraser and we should just rub out all those little connector lines. Okay, they're not really part of the answer. And we should probably take off that diagonal highlighter pen as well. So we might do that at the end. We'll have to go back and edit the original PowerPoint slide. Yeah, so you've got to take off all these connectors. You can draw them in with pencil or pen on your screen while you're working them out, because that's how we get them worked out. But for the final answer, like if you're doing this on a SAC or a test, don't leave all those connector lines in. That would look very unprofessional and incorrect. And we've got to get off those diagonal lines.